folks, Ms. Vernon here. Just in to talk a little bit with you today about sequences and series, specifically arithmetic and geometric. We just finished up our unit involving this information, and some of you have expressed some frustration. We have two different types of sequences that we can have. We can have arithmetic or we can have geometric. An arithmetic is a sequence that we are adding the same amount each time, while a geometric is a sequence where we are multiplying by the same number each time. A sequence has terms. These are going to be a list of numbers. Okay? Where a series is when you add up the numbers. From the sequence. We have two different types, and when you're dealing with arithmetic, we really will only have one formula we use. To find the sum of a finite number or just a few terms in an arithmetic series, we're going to use this formula. N stands for the number of terms. So I want to find the sum of 1 to 20. I would put 20 there. U sub 1 is the first term. And U sub n is the nth term. Okay? With geometric, if it's a geometric, we have to decide, are we finding the infinite sum or are we finding the partial sum? The infinite sum means that n is infinity. We don't ever stop adding. We just keep adding and adding and adding. So this will only work if our ratio is less than 1, because those types of problems will level off to a specific number. If I want to find the partial sum, I'm going to use this formula over here. In both of these formulas, U sub 1 is just the first term, and R is known as our common ratio. Let's go ahead and take a look at an example. In this example, they gave us a list of numbers. This is a sequence of numbers, 2, 6, 18, 54. Quickly, I can tell that it's not adding the same number each time, so therefore it must be a geometric sequence. If it's a geometric sequence, it means we have a common ratio, and we can find the ratio by taking two consecutive terms and dividing them. In this case, our common ratio is 3. Once I know my common ratio, I can use that information to help me find the 15th term and then the sum of the first 15 terms. If I want to find the 15th term, it will be helpful for me to first find our formula for this. Our formula for a geometric sequence can be found by using U sub n equals U sub 0 times r to the power of n. If 2 and to go to 6 we multiply by 3, to go backwards, we would divide by 3. That means that U sub 0 in this case will be 2/3. We said our common ratio was 3, and we were raising it to the power of n. That means if I want to find U sub 15, I can now use this formula by plugging in 15 for the n. 3 to the power of 15 times 2/3 is going to be a very large number. It's going to be 9,565,938. So far we found the 15th term. The 15th term is 9 million, which means the sum of the first 15 terms is going to have to be greater than that. To find S sub 15, we're going to use that third formula I gave you above, which is the formula, just pop up and take a peek at that. S sub n equals U sub 1 times 1 minus r to the n divided by 1 minus r. So we are going to use that formula. We know that U sub 1 is 2. We can get that by looking at our sequence above. 1 minus r is 3, and we want to raise just the 3 to the 15th power. And then we're going to divide that by 1 minus 3. You can type this all into your calculator just as you see it, and when you do that, you will get that the sum of the first 15 terms is 14,348,906. Let's let's go ahead and take a look at another example. The next example we have here is it's asking us to find S sub 10 given the series that is listed. This is a series because there's an addition sign between each of the numbers. Okay, the first thing I'm going to do is I'm going to identify, is it arithmetic or geometric? 16 to 24 to 36 is definitely going to be a geometric series. To figure out what kind of ratio I have, I can take the second term divided by the previous term, and in this case, I get 1.5. Okay? Now, because I'm looking for S sub 10, I don't need to write the explicit formula for this because my sum of my first 10 terms does not require the use of n formula. So if I want to find S sub 10, I'm going to go ahead and take my first term, which is 16, and multiply it by 1 minus the ratio of 1.5 raised to the power of 10. Then I'm going to divide that by 1 minus 1.5. This again is just that formula from above. When I do this math, I get 1,813.28. That means that if I add up the first 10 terms, this is what my sum will be. I have one more problem for us to take a look at. Now, when I look at this one, it's written in yet another way. This is using our summation notation, which basically is just saying, find S sub 3, the sum of terms 1, 2, and 3. To do this, I need to decipher what this part is saying. Well, this is my explicit formula, and in order to use my S sub 3 or my S sub n formula for a geometric series, I need to know my first term, and I need to know my ratio. To find my first term, I can do that by plugging 1 in for n. So I'd have 0.3 times 0.1 raised to the 1 minus 1. I can type this into my calculator and I get 0.3. Find my common ratio. Well, the ratio is just the number that is below the exponent, and in this case that is 0.1. So if I want to add up the first three terms, I would take 0.3 times 1 minus 0.1 raised to the third, because it is the third. I want to find the sum of the first three terms, and then I go 1 minus 0.1. When I type this into my calculator, I do end up getting 0.33 repeating, or 0.3 repeating, which is the equivalent of 1/3. So the sum of the first three terms here ends up actually being 0.3 repeating, or 0.333. I hope this information is helping you a little bit with our new formulas, which were our geometric series, whether it's infinite or finite. Again, it's just formulas. Remember that your formulas are listed here, and they also do show up on that note sheet that I give you, that blue sheet. So go ahead and identify where those are while doing your homework over the weekend. And don't forget, you have that homework quiz due on Monday.